tutorial on the 9-point circle. Okay, so 9-point circle is to do everything with the medial triangle. In my previous video, I've shown you what the medial triangle is, some of its basic properties, and the most important thing, that it divides the triangle into 4 congruent triangles. Okay, so coming straight with the picture, here you go. Okay, I'm taking any damn triangle ABC. Okay, okay. This is not necessarily an isosceles or an equilateral triangle. I label it A, B, and C. Okay, so I'm drawing a medial triangle, right? I don't need to explain you what exactly those are, because I think you should be knowing this, or you can check out my previous video. Okay, A1, B1, C1, they're special points. BA1 equals A1C, AB1 equals B1C, and AC1 is equal to C1. Okay, cool. Now what I do is join these points. Okay, C1, B1 is there. Okay, I'll use another color, say red. Sorry. Okay, there you go. C1, B1, B1, A1, and A1, C1. Okay, so this is your medial triangle. Now what I'm going to consider is one circle, that is the circumcircle of the medial triangle A1, B1, C1. So this circumcircle of A1, B1, C1 has 6 more points other than A1, B1, and C1. And those 6 points I'm going to show you all today. So the first point, I'll be using that label, say A2, B2, and C2. So what is A2? Okay, so what I do exactly is I drop a perpendicular from A. Okay, 1 second, I'll make that a bit more cleaner. Oh, sorry. Anyways, very sorry for this. Okay, this is a triangle. Now what I do is I'm dropping perpendicular from A. There you go. Okay, and this is perpendicular. Note that. Now what I do is I want to prove that the circumcircle of A1, B1, C1 actually has this special point, which I'm labeling A2. Cool. So I prove that A2 lies in the circumcircle of A1, B1, C1. Let's go with it. Okay, so I'm going to show you the proof of this. It's quite simple. A1, C1 is equal to C1B is equal to A1B1. That comes thanks to my point here. Okay. On the same lines, what I do is I join A2C1. Okay. Observe triangle ABA2. Okay, it's a right angle triangle with right angle at A2. Okay. And ever since this comes, and you see medians in a right angle triangle, this is the most commonly part which comes. That is, if you have a right angle triangle and this is your median, so this length is equal to this length is equal to this length. Okay, it comes very simple. You can see, you consider the circumcircle, and you can see this is actually the center because this angle is 90 degrees. Okay, this is a 90 degree. So I can say this is the center, hence all these radii and radii are congruent. Okay, so it comes from that. So purely on this idea, I get this point A2 right here. Okay, so what I do, just mark them equal, right? Okay, and I know one more property, that C1, B1 is parallel to BC. Okay, so as a result, I get A2, A1, B1, C1 is an isosceles trapezium. Okay, that will come because we now got that A1, C1 is equal to A1, B1. Yeah, thanks to midpoint theorem and the right angle triangle. Okay, so this is a basic idea which we're going to develop further. Okay, moving on. So isosceles trapezium done. What is the specialty of an isosceles trapezium? We'll see that. Okay, Please note this, you can have a note of this, very important property, that an isosceles trapezium is actually a cyclic quadrilateral. Okay, this is a property, or say a theorem. I can call it a property maybe. Okay, so this is always a cyclic quadrilateral. Okay, it has some very simple proofs I'll show you in some other videos. Okay, so now this isosceles trapezium is actually a cyclic quadrilateral. So as a result, I'm getting that A1, A2, C1, B1 is a cyclic quadrilateral, right? So I'll write that down. A1, A2, C1, B1 is a cyclic quadrilateral. As a result, we get A2 lies on the circumcircle of A1, B1, C1. Cool. So we get on the same lines, I'll take a point B2, that is, I'll drop a perpendicular from B onto this side. Okay, right here. And this is 90 degree. So I get a point here which is B2. Now what I do is I take another line from C. Okay, so I know they're congruent, so you'll meet at one point. There you go. This is 90. And please note, so this is actually your edge, okay? Your edge of the center. So on the same lines, what I get is, okay, this is C2. That actually on the same circle, which is the circle of A1, B1, C1, I get 3 more points, which is A2, B2, C2. Cool. Okay, let's move further. Now I'll get you another diagram to show you which is exactly the third point. Okay. So I'll take a new note for that. There you go. Okay. So I'll do this quick. This is a triangle ABC. Okay, ABC. And what I know is I'm dropping perpendiculars from A, from B, and from C. Okay, meeting an edge. I have some more special points. I have A1 here. Oh, sorry, I'll take A1 here. I have B1 here, and I have C1 here, and these are mid points. Okay, I'm not showing those. It becomes really complex. This is your orthocenter edge. Okay, so A1, B1, C1. Okay, midpoints. And what I do is, the third point which people have observed, or it comes with a good proof, which I'll show you, is the midpoint of segment AH, BH, and CH. So the midpoints of these three segments, okay, midpoints of segment AH, BH, and CH actually also lie on A1, B1, C1. Okay, so now I'll teach you this very important concept of how to derive on a proof. Like you saw proof on the same lines, I'll prove this one, that the midpoint actually lies on the circle of A1, B1, C1. Okay, first thing, what you do is plot the point. Okay, I'm calling it A3. Okay, that we things become easy for us. I'm noting it A3. See, I'll be using these notations because they're the most common ones. Okay, so A3 is midpoint of AH. Okay, I'll just mark that. Say this is congruent to this. Okay. Okay. What else I know? AB1 is equal to. Okay, sorry. AB1 is equal to B1C. We know that, right? Because B1 is actually the midpoint. Okay. It is actually the midpoint, right? B1. Okay, this point here, B1. So we get, as a result, what I do is I'm just joining A3, B1. Okay, I'll just erase A3 and write it on the other side. Say I'll write it here, A3. And now what I do is I just join A3, B1. I use red. Oh, sorry. I'll use a line there. Okay, where's my point? B1. Yeah, there you go. B1. What I get is again coming from the most famous theorem, the midpoint theorem. What I get? Observe triangle AHC. Observe this triangle. Okay. So this triangle will be forming a major part. AHC, on the side AH, I have midpoint A3, and on the side AC, I have midpoint B1. What I do, I just use them up and I get the midpoint here. Cool, right? So A3B1 becomes parallel to HC. Cool. What I do next is, okay, so what we do is we join A1, B1, okay? This is gonna make the diagram a bit complex. Okay, so what I do is I just write H on the other side. Okay, because I'm joining A1, B1. See, what you want to prove if you want to prove it's a cyclic quadrilateral, see, I'm going with the approach that I want to prove that A1, B1, A3 is actually forming on the same circle of A1, B1, and C1. So an approach would be, a good approach would be to prove two angles 90 degree. Correct? That's a very good approach to proving as cyclic. So what I do is now A3B1 is parallel to HC, and I join AB1. I join A1B1. Sorry for that. A1B1. And I know that A1B1 is actually parallel to AB, right? Thanks to midpoint theorem. Okay, A1B1 is parallel to AC. Now observe lines CH and AB. Okay, CH and AB. Okay, what you get in CH and AB? Look at that. Okay, I should get this rubbed off. CH and AB. What you get in CH and AB? Sorry. What you get is CH is perpendicular to AB. Correct. I know A3B1 is parallel to CH, and I know that A1B1 is parallel to AB. Cool. So what we get is, as a result of both these, which I'm going to write up here, it's going to form a crux, is that A3B1 is perpendicular to A1B. Okay, so please understand here that why we proving 90 degree. Because if we prove two angles to be 90 degree, we're done with proving that it's a cyclic quadrilateral. So as a result, please look here, I get this angle as 90 degree. Oh, awesome. Okay, well, if you want to know from where this comes, I can say, like, if this line is and this line has an angle theta, if I have a line parallel this way, so this angle will also be theta. Okay, comes basically from there. That's obvious, so you can actually prove that very easily. I won't prove that actually too easy or too basic stuff. Okay, moving on. So now what I get is A3B1A1 angle is equal to 90 degree. Okay, so we prove 190 degree, right? So what I do is okay, I'll take this point A2, right? I like this point A2 here, and I know this angle is 90 degree, right? So as a result, I'm getting something more. I'm getting that A3, B1, A1, A2 is cyclic, thanks to 90 degrees. Okay, is this clear? Okay, it should be. Here with me. Okay, so I get this is a cyclic quadrilateral, and I know that A2, A1, B1 line one circle, which is actually the circumcircle of triangle A1, B1, C1, right? It's actually the circumcircle of this triangle, which has points A2, A3, A2, and as a result of this A3, because this is also a cyclic quadrilateral. So we're done with this discussion, so I'll just sum it up in 2 minutes. What I'll say is the circumcircle, okay, I'll note this way, of A1, B1, C1, see, I'm referring to triangle, has 9 points. 9 points. Okay, I'll just highlight that.